All right, let's dive in. Get ready to go way beyond what you can see in your backyard telescope. We're going to be talking about star birth, supernovae, and we're going to be checking out this spiral galaxy called NGC 1637, which is, get this, 38 million light years away.
Yeah, that's mind-boggling, isn't it?
It is. It is. And what's even cooler is that we have this brand new image from the Hubble Space Telescope to help us along the way.
Yeah, and this image, it's not just some pretty space picture. Astronomers are actually using this to really understand how stars form in other galaxies.
Oh, okay. So before we get too deep into the science, though, could you maybe set the scene for us? What are we actually looking at in this image?
Well, just imagine this swirling mass of stars, gas, and dust. And right at the center, there's this warm yellow glow coming from a bunch of older stars. And then throughout the spiral arms, you see these brilliant blue stars, which are like the young hot stars of the galaxy. And then you have these massive clouds of pinkish gas, which are just spectacular.
Wow, it sounds incredible. I can't wait to see this online later. But honestly, it's kind of hard to imagine just how huge these structures really are. So where do stars even start in all of this?
Well, it all begins in those massive clouds of gas and dust. And I mean, truly enormous. We're talking about clouds spanning light years across. And these clouds, they're incredibly cold, much colder than anything you could ever experience on Earth. But inside them, gravity's always working, pulling everything together.
So gravity is kind of like the sculptor of the universe then, right? It's slowly shaping these clouds into something new.
Exactly. And as gravity pulls that gas and dust inward, the cloud begins to collapse. And as it collapses, it gets denser and hotter and hotter. And eventually, the core of that cloud gets so hot and so dense that nuclear fusion ignites. And boom, you have a star.
Okay, so we've got a star, but I have a feeling it's not just hanging out there. What happens next?
Well, you're right. Newborn stars are anything but passive. As they grow, they start influencing everything around them. They've got these powerful stellar winds, intense radiation. They're even spewing out materials, kind of like they're having a cosmic tantrum, you know?
I like that, a cosmic tantrum. Interesting. So a star's birth is not a quiet event. Now, what about those pink clouds that you mentioned before? They're not just there for looks, are they?
Oh, definitely not. These pink clouds are actually regions called HI regions, and they're a sure sign of star-forming activity. That pink color actually comes from excited hydrogen atoms. And you know those hot blue stars we talked about? Well, they blast out huge amounts of ultraviolet radiation, and that energizes the hydrogen, making it glow that distinctive pink.
Wow, so those young hot stars are literally lighting up the areas where new stars are forming. It's like a chain reaction. This is incredible. This one image tells us so much about the life cycle of stars. But speaking of life cycles, we can't forget about that grand finale, the supernova. NGC 1637 had one back in 1999, didn't it?
Yeah.
SN 1999, EM.
Oh, yes, that's right. And supernova are more than just, spectacular cosmic fireworks. They're actually essential for how galaxies evolve. And this Hubble image is really helping us figure out why.
Okay, I'm intrigued. Break it down for me.
So when a massive star reaches the end of its life, it basically runs out of fuel. And without that outward pressure that the fuel was creating, the core just collapses. And that collapse triggers a shockwave, blasting the star's outer layers out into space with incredible force.
Wow, that sounds pretty intense. How much energy are we talking about here?
Okay, try to imagine this. A single supernova can release more energy in a few seconds than our sun will in its entire 10 billion year lifespan.
No way.
Yeah, it's insane. It basically outshines its entire galaxy for a little while, and all these elements forged deep inside the star's core get scattered across huge distances.
That's mind-blowing. But all this destruction, it can't just be about the end, right?
You're right. Supernovae are actually like cosmic recyclers. Remember all those heavy elements we talked about, the ones formed during the star's life? Well, those get scattered into space, and that enriches the interstellar medium. And those elements, well, they become the building blocks for new stars and planets.
So from the death of one star, new worlds can be born. That's a beautiful cycle.
It is. It's a cosmic circle of life. And remember those shock waves from the explosion? Well, they slam into nearby clouds of gas and dust, and that can trigger even more star formation.
So a supernova's death throes can actually lead to the birth of new stars. That's incredible. It really shows how interconnected everything is in the universe.
Absolutely. But there's actually more to this story. We've been focusing on these big dramatic events, but the quieter parts of the galaxy play a role too.
You mean all that gas and dust we see swirling around? It's not just an empty backdrop.
No, not at all. Astronomers call it the interstellar medium, and it's a dynamic environment filled with gas, dust, magnetic fields, and even cosmic rays.
So it's like this cosmic soup that everything swims in. What can this image tell us about the interstellar medium in NGC 1637?
That's a great question. By studying the light coming from different parts of the galaxy, astronomers can actually figure out what that gas and dust is made of. They can even tell how dense it is in different areas.
Wow, so this Hubble image is like a detailed map of the galaxy's building blocks.
Exactly.
It's incredible. But what's really fascinating to me is that this interstellar medium isn't just sitting there. It's constantly changing, being shaped by the stars around it.
That's right. It's a really dynamic relationship. Stars are born from the interstellar medium, and then their entire lives and even their deaths affect it. Like those powerful stellar winds we were talking about, they can carve out huge cavities in the interstellar medium. And those cavities can then trigger the collapse of other clouds, sparking even more star formation.
So it's like this incredible dance between the stars and the interstellar medium, each one shaping the other over millions and millions of years.
Precisely. And understanding that relationship is a key part of figuring out how galaxies evolve.
It's amazing. We can actually witness this cosmic choreography from millions of light years away.
It really is remarkable. This Hubble image gives us a front row seat, and it helps us understand how stars form and die, and how those events actually shape the galaxies themselves.
You know, we talk a lot about these big questions in astronomy, like where did the universe come from? Is there life out there? But even these smaller questions, like how do stars live and die, those are just as fascinating, aren't they?
I completely agree. Understanding these fundamental processes, all the little details, helps us connect the dots and really grasp the bigger picture of the universe.
Absolutely. Now, speaking of details, what are some of the mysteries that astronomers are still trying to figure out about star birth and supernovae? So what are some of those mysteries? What are the things that really puzzle astronomers?
Well, one of the biggest ones is figuring out exactly what triggers star formation. We know that gravity is key. It pulls all that gas and dust together, but it's not the whole story. There's got to be something else going on too, like maybe turbulence inside those giant clouds or magnetic fields or even shock waves from nearby supernovae.
Oh, wow. So it's not as simple as gravity saying go and then a star appears.
Yeah.
It's way more complicated.
Yeah, it really is. It's kind of like trying to bake a cake without a recipe. We have the ingredients, but we're still figuring out the exact measurements and the order to mix everything to get that perfect star formation recipe.
I like that analogy. And I bet supernovae have their own mysteries too, right?
Oh, absolutely. For example, we're still trying to fully understand how those massive stars actually explode. Like, what are the specific things that have to happen? And how do different types of supernovae, how do they vary in their energy, the elements they produce? Those are some big questions.
It's incredible, isn't it? We're talking about these incredibly powerful events. They can shape entire galaxies, and we still have so much to learn about them.
Yeah, and it's not just about the explosions themselves either. It's about what happens afterward. Supernovae don't just disappear. They leave behind these expanding shells of gas and dust called supernova remnants. And those remnants, they can really impact the galaxy. They can influence how many stars are forming. They can heat up the interstellar medium. They can even create these galactic winds that push gas out of the galaxy completely.
Wow. So supernovae are like these cosmic influencers, shaping the galaxy long after they're gone. It makes you wonder, what other chain reactions are out there? What other connections are we missing?
Exactly. That's what makes astronomy so exciting. There's always something new to learn, to discover. Every new observation, every new piece of data helps us understand the universe a little bit better.
It's truly amazing. We started this deep dive by looking at an image of NGC 1637. But we've gone on this incredible journey. Through the entire life cycle of stars, we've seen this cosmic dance of creation and destruction.
We have. And that Hubble image, it's just a glimpse into this vast, awe-inspiring universe.
It really shows how everything is connected, doesn't it? From a star being born in a cloud of gas and dust to the explosion of a supernova that creates the building blocks for new worlds.
It's a humbling thought. And it reminds us that we're all part of this cosmic story. We're made of stardust,
Stardust from stars that died long ago.
Wow, that's beautiful. I think the next time I look up at the night sky, I'm going to see it differently. It's not just a bunch of twinkling lights anymore. It's a tapestry of the lives and deaths of stars. It's a story of cosmic evolution.
Exactly. And who knows what else is out there waiting to be discovered? Every new observation, every new finding pushes the boundaries of what we know. And it keeps us asking questions.
Well said. I think it's time to wrap up our deep dive into NGC 1637. But before we go, I want to encourage everyone listening to check out that Hubble image online. It's a breathtaking reminder of the beauty and complexity of our universe. Until next time, keep looking up and keep exploring.